I have to check on the computer, every day just to see, okay, are there some new planetary discoveries? Is there some new breakthrough? I can remember going to conferences in which, like it was just every day there was some jaw-dropping result that was released. And the poster sessions, for those of you that aren't familiar with scientific meetings, so there are talks, presentations that people give, but there are also posters. It's kind of like an adult version of a science fair, where scientists, basically by 1 meter by 1 meter space, have to put up a poster that describes their research, and then they stand by it and kind of answer questions, try to draw people in, come and talk to me, here I've got coffee. And at one of these conferences, the plots on the poster of the data were being updated every day, like results that were coming in from a satellite. That was just unheard of, it was just, we live in that kind of era. It's revolutionary. And it's maybe appropriate that I describe it as revolutionary, because the word revolution used to just mean circular motion. When Copernicus wrote his book on the fact that the sun should be at the center of the solar system of the known universe, and he wasn't the first person to come up with this idea, but he presented the case in a way, and at a time when observational data were on the horizon to test these ideas. And his book was published posthumously. His assistant, Rheticus, published it after Copernicus died. But the title of the book was De Revolutionibus, on the revolutions of the planets, on the orbits of the planets. And that book had such an impact, the ideas within it, overturning society and religion so profoundly that people started to use the word revolution to mean an overturning of thought in society, an overturning of politics, an overturning of religion. And so had Copernicus chosen another word for the title of his book, who knows? We might be using a different word than the title of the Beatles song, and so on might be something completely different. But it is ingrained in our very language, these kind of planetary revolutions, these astronomical, eye-opening moments, even in ways that we don't realize. So that any time that you hear somebody use revolution in any way other than circular or orbital motion, they are doing so because of the heliocentric revolution in the late 1500s and early 1600s. And so that scientific sense of discovery is woven into our language.
So how close do you think the next revolution is? What is it? Is it another Earth? Is it life? How close are we to these things?
The revolution is going on right now. I tell people, and I believe it quite sincerely, that 400 years from now, people will look back at today, this decade, the decade to come, this century, without question, in the same way we look back at the time of Galileo. It is literally that revolutionary, not just in terms of planetary and exoplanetary discovery, but in so many aspects of astronomy. You go back less than 100 years, and scientists believed that the Milky Way was the entire universe. They believed that we were almost at the center of the known universe. Even though we weren't at the center of our solar system, it looked like to many scientists that we were at the center of the known universe. Scientists believed until the late 1920s that the universe was primarily made of iron. And it was a pioneering young woman, Cecilia Payne, who later married a Russian astronomer, Cecilia Payne-Gaposchkin, who in her PhD thesis at Harvard in 1927 first did the physics correctly to interpret the spectrum of the sun and other stars, and showed us that the sun and other stars are made up primarily of hydrogen and helium, and that iron is just one of those little spices in the recipe. It's just our perception of the universe. The recipe of the universe I talked about before. When I was a student, it was like just 100% of it was the atoms and the molecules that make up you and me and this planet and the sun and the other stars and the gas between it. And now that's relegated to 4%. Our entire conception of the composition of the universe has been completely transformed in 40 years. And so we're just too close to it. And the information propagates so effectively now in our era of social media that I don't think people are well, it's great because anybody who has a smartphone can tap into this information. I don't, by the way. I'm a zero cellular organism. I'm a Captain Kirk without a communicator. I do not have a cell phone, just because my life is ruled by voicemail and email, and I don't want it to follow me around any more than it does. But I will grant you that the kinds of electronic communication we have today puts in everybody's hands a lot of the latest results. And so that's a great thing, but it's also maybe it diminishes the impact, is because people don't quite realize the fact that they have access to these discoveries so soon. They may not realize the true importance, the weight, the magnitude of those discoveries. And I'm speaking just for what's going on in astronomy and astrophysics, but you're seeing the same kind of revolutionary transformations in genetics, in areas of biology and nanotechnology and quantum computing and cryptography. And so, boy, this is a great time to be a scientist, or it's a great time just to be interested in science. I mean, every era in human history, there were great leaps forward in science, but just the sheer breadth and variety of things that are happening today, that have been happening through my life as an astronomer, as a student, as a human being. When we talked earlier in our conversation about going back in time and having a redo, again, I just can't think of a way in which this would be a more exciting era, except possibly being contacted by aliens or discovering evidence for life on another planet, life 2.0, and I shared with my students, and you were there today, that I boldly predict that within about 20 years, somebody will be announcing the detection of a biosignature, evidence in the infrared spectrum of a system with an M-dwarf star and a planet in the habitable zone of microbial life. And it will happen in our lifetimes. And it can't get more exciting than that. And so, yeah, maybe there is still the finale for this particular part of the story, and it's never a finale. There's always another act. But I've got to admit, in terms of what's been happening now and what I can foresee for the near future, we've already been experiencing just an incredibly exciting and fulfilling era of discovery. And for myself, like I said, maybe just having that definitive evidence of life elsewhere. And if it's a race, to be honest, I think the exoplanetary astrobiologists will probably win the race over the people searching for life on Mars. And if it's a race for life in our solar system, to be honest, that race might be won by people who are studying and eventually sending probes to the moons of Jupiter and moons of Saturn, like Europa around Jupiter and Enceladus around Saturn, which have subsurface oceans, where if I had to bet on it, if there's life elsewhere in our solar system right now other than the Earth, I would, if I had to go to Vegas, I'd put lots of chips on Europa and Enceladus, and maybe even some of the other moons of the Jupiter and Saturn systems, and only a few chips on Mars.
Yeah, so I think the one thing I still want to ask you is, like, it's more of a purpose question. It's like, what is driving you? Is there like one thing that you're going after? Is there a set of things you're looking after? Is it the future of humanity? Is it just exploratory, or is there something in specific that you're still trying to solve?
Well, it's interesting the way that you've phrased the question. Ultimately, the reason why I study distant suns and search for and study distant worlds is to better understand our own sun and to better understand our own world. If you were going to understand the Earth and how it interacts with the sun, we need other examples, and we haven't had them. And in issues in which it looks like our environment is changing in a way that we will have to adapt to, and that maybe we can take an active role in influencing in a more positive way. To be able to understand climate and how it would work to the breaking point. Like if I were a metallurgist, if I were a chemist or a physicist, and I wanted to understand a material, to truly understand the material, I would want to test it to the breaking point. We would like to truly understand the Earth, but we don't want to test it to the breaking point. We might be doing that, but we don't want to do that. But nature is doing it for us. There are worlds out there with environments that are just so extreme that even science fiction writers would have rejected them. A planet like HD 80606b, which has this extremely wonky eccentric orbit, which has a year of 112 Earth days. So it goes around its star once every 112 days. And at its greatest distance from its sun, it's about the distance that we are from our sun. But then it swoops almost over top of the surface of its star. And it goes from the distance of Mercury from the sun to almost on top of its sun in a week. And in that time, the amount of light that it receives from its star goes up dramatically, and that means that the heat that it gets goes up dramatically, or that it emits goes up dramatically, and the weather changes. Now here in Vancouver, we can talk about, and in Montreal as well, the weather can change over a few hours. It can be clear, then it's cloudy, then it's raining or snowing, and then it's back to clear again. I'm not talking about the weather changing in a few hours in one place on the planet. I'm talking about the weather changing in the same way in a few hours everywhere in the planet. It's a climate roller coaster. Some models that former undergraduate students working with me had done for this planetary system predicted that the temperature would go up by 400 degrees Celsius in a week and then drop by 400 degrees Celsius in the next week. That's why I call it a climate roller coaster. And like I said, science fiction writers had never really dreamed of places like this. If I'd gone up to George Lucas when he was writing Star Wars and said, hey, George, we want to discover this planet, HD 80606b, you got to put it in your new movie, he would have rejected it as being too outlandish. And this is the guy who came up with Jar Jar Binks. And so we have examples now of systems that undergo such extreme changes that we can test our models of the environment, of climate change, of the interaction between a star and its planet, whether it's the solar wind and the magnetic field, or whether it's the radiation field and the atmosphere and the ozone layer. And so ultimately, the reason why I'm curious about these distant planets and why I'm so curious about these distant stars is really to teach us more about our home. And I think that's the thing that justifies what I do. Yes, it would be cool to find aliens, and yes, I grew up as it's an occupational hazard to be, if you're an astrophysicist, to be a science fiction fan growing up. So yeah, it's super cool that we're studying like alien worlds, and that we might, in my lifetime, find evidence for life on one of those worlds. Doesn't get any cooler than that. But at the end of the day, whenever I do finally get to bed, and I don't get to sleep very much, but when I do, I can take a breath and say, we're one step closer to better understanding the world in which I grew up, and the world in which I and my friends and my family and all human beings are living the rest of their lives. And I can't think of a better justification or motivation for what I do than that.
I'm sold. Is there I guess we'll wrap this up. Is there any place that you would like people to go online for like more information on this stuff, or your particular research, or anything that you think would be cool to let people know about? Do you have a Twitter handle?
You've caught me. Yes, I do have a Twitter handle, which is also Dr. Libido. My Skype ID is dr.libido. I'm on Facebook as Jaymie Matthews. We do have a website for the Most Space Telescope, but it's horribly out of date, and so I really wouldn't want to direct anybody to that. But to be honest, in the same way as if our viewers here Google your name, Tim Blais, or Acapella Science, and they will find all sorts of really interesting and intriguing stuff. It's true if you just Google Jaymie Matthews, Jaymie, Matthews with 2 T's. Google Video will show up lots of interesting interviews, public talks, DVD extras to science fiction movies like The Layman's Guide to Time Travel. So I have a kind of a web presence that's not gathered together or curated in one site, but I invite people. That's the way science works: is go out there and explore, and the deeper you dig, the more you'll find. So if you just do a basic search for Jaymie Matthews, you'll find lots of stuff. But if you're clever, if you're a good scientist, and you find the right keywords to put in the search window, you will find some very, very interesting stuff.
Having Googled you before this interview, I can attest to that. If you people online want to go and see the interesting incident of how Jaymie Matthews got a moon rock at the age of 13, and other such tales. Jaymie?
Yep.
Thanks for coming on.
It's been a pleasure. Thank you.
And being my debut guest.
Your guinea pig. Again, that's what science is all about. So I was happy to, play my small role in the expansion of knowledge and pushing back the frontiers of human ignorance.
Well, thank you very much.
Thank you.